Corrosion, the result of nature's attempt to return a metal to its original natural state. It is defined by the National Association of Corrosion Engineers as a deterioration of a substance, usually a metal or its properties, because of a reaction with its environment. Corrosion is recognized as one of industry's most difficult and damaging problems. In the United States alone, the cost of losses due to corrosion has increased dramatically. In 1978, the losses were estimated at approximately $70 billion. By 1986, that figure had risen to an estimated $180 billion. Today, it is estimated that over $250 billion annually is lost due to the effects of corrosion. Corrosion of a buried metal is greatly influenced by the conditions in the soil in which it is buried. These major soil conditions are type. What is the most content? Is it sandy? Is it loam? Is it clay? Or is it a combination of these? Mulch increases corrosion. Drainage. How well the soil retains water. Moisture increases corrosion. Resistivity. The lower the resistivity, the more corrosive the soil. Acidity. The lower the pH, the more acidic and the more corrosive the soil. However, alkaline soils can contain dissolved salts, which can accelerate corrosion. And particle size. Larger soil particles can allow oxygen to penetrate to the buried metal product. If an area with an abundance of oxygen is next to an area with a limited supply of oxygen, a differential aeration corrosion cell is created. The original texture and drainage of a soil can be adversely affected in a backfill ditch. Even though the backfill is compacted, it becomes less dense as depth increases. This allows water and oxygen to penetrate the backfill to the area where the piping system is located. Moisture can collect at the bottom of the ditch in the soil next to the pipe. Organic material dispersed throughout the backfill can contribute to the growth of bacteria, which will further enhance the corrosiveness of the soil. Of the many different types of corrosion, the most common to underground piping systems is concentration cell corrosion, also called differential aeration corrosion and crevice corrosion. It defines corrosion which has the tendency to build up more rapidly in cracks and crevices, or between overlapping layers, where there are less oxygen molecules available to the surface of the metal. This area becomes anodic, and the current flow is from this point to an area where more oxygen is available to that metallic surface. As the current flows from the anodic area, metal ions leave the product and go into solution in the surrounding soil, creating pitting and corrosion in the metal surface. Even stainless steel is not immune to attack by crevice corrosion. The chromium oxide film on stainless steel can easily be broken down in crevice areas where oxygen concentration is reduced, such as under the head of a bolt or between layers of an assembly. In the electromotive series, commonly called the galvanic series, where metals are listed in order of their ability to corrode, magnesium and zinc are less noble than steel and are used to protect steel pipelines and steel tanks of water heaters. The MG coupling was engineered and designed to combat the forces of concentration cell corrosion or differential aeration corrosion. Its unique cast iron and stainless steel construction provides a galvanic cell. Cast iron is less noble than stainless steel. Thus, in the presence of an electrolyte, the soil, the cast iron clamps of the MG coupling become anodic to the stainless steel bolts and nuts and provide full cathodic protection to them. Because the cast iron clamps and the stainless steel bolts and nuts are relatively close to the galvanic series, and more significantly, because the cast iron clamps are decisively larger compared to the small cathodic area of the stainless steel bolts and nuts, the protecting current is small and causes no substantial change or damage to the cast iron clamps. As a result of extensive testing and corrosion studies, it was concluded that the MG coupling would have a life expectancy as great or greater than that of the pipe to which it is attached in the same soil environment. Actual use in the field verified its strength and resistance to corrosion. It is the only coupling for the hubless cast iron soil pipe system to be tested for its resistance to concentration cell corrosion. The resistance was measured in millivolts. None of our competitors' couplings have been tested as a coupling assembly for resistance to concentration cell corrosion. Because of its unequaled resistance to corrosion, the MG coupling with hubless cast iron soil pipe is an excellent replacement for service weight cast iron hub and spigot soil pipe used in underground sanitary and storm drain systems. The MG coupling provides a stronger joint and is easier to install. Above ground, the MG coupling provides a strong joint, especially on large diameter storm drain systems. The bolts and nuts are torqued to 175 inch-pounds, 2 to 3 times the torque applied to the worm screws of other hubless couplings. This high torque provides the highest radial compression of any coupling, holding the joint together and resisting in-pull and deflection. The MG coupling joint is so strong that during the January 1994 6.7 earthquake in the Los Angeles area, none of the MG coupling joints came apart in a large postal distribution facility close to the epicenter of the quake. Even though there was structural damage to the building, the MG coupling held the 8-inch and 10-inch pipe and fittings together in the above-ground storm system. Compared to other types of couplings for joining hubless cast iron pipe and fittings, the MG coupling has the best resistance to crevice corrosion. In addition, the MG coupling is unequaled in strength. It meets all the requirements of ASTM's
A1056,
the standard specification for shielded couplings joining hubless cast iron soil pipe and fittings. MG couplings are quicker and easier to install than hub and spigot joints because no machine is needed to push the joints together. The MG couplings join system requires less support than hub and spigot systems. Joints stay in line and in place during testing and prior to backfilling. There is less wasted material with an MG coupling joint system. Since each piece of pipe does not need an integral hub, material savings can average 15%. Material needs are easier to estimate with MG couplings, hubless pipe, and hubless fittings. These materials are more readily available in local wholesaler inventories. For over a quarter of a century, MG couplings have been providing high-strength corrosion-resistant joining systems on commercial and institutional buildings in the U.S., Canada, Mexico, Europe, and Africa. Its use allows the economies of the hubless system throughout the building, both in the ground and above, without sacrificing resistance to corrosion or strength. When using MG couplings, you will be assured that they will be doing their job for as long as the system is in service in any environment, above ground or below.